The Burj Khalifa stands 2,717 feet above Dubai, but the part that decides how long it keeps standing is 12 feet thick, and it is buried underground where nobody will ever look at it again. It is a concrete raft, and Dubai paid for it twice, once to build it, and once a year, every year, ever since. 12,500 cubic meters of concrete, poured in 4 separate pours, sitting on 194 board piles that reach about 141 feet down. Each pile was designed to carry 3,000 tons, and the test piles were loaded past 6,000 tons before anybody signed anything. That foundation was one of the largest single items inside a tower that ran to roughly $1.5 billion. At first, this might just seem like ordinary engineering. Every tall building has a foundation. Every foundation is boring. But the groundwater that raft sits in is not ordinary groundwater. When the engineers tested the site before construction, the samples came back with chloride concentrations of up to 4.5% and sulfates of up to 0.6%. Ordinary seawater runs closer to 2% chloride. Dubai poured the foundation of the tallest building on Earth into liquid roughly twice as aggressive as the Persian Gulf, sitting 3 miles away. Here is the part you can feel in your own hands. If you have ever pulled a rusted bolt out of a fence post near the coast, you already know what salt does to steel. Now put that steel inside concrete, under a building that weighs around 500,000 tons, and try to reach it. You cannot. Nobody can. That is the whole story. To understand what Dubai actually built here, you have to stop looking up at the spire and start reading the receipt for the part underneath. The tower was announced in 2003, and excavation began in 2004. The raft went in over the following 2 years, in 4 pours timed to control the heat coming off that much cement at once. Those pours ran through the night, because the workers pouring them needed the cooler air, and because concrete that sets too fast in Gulf daytime heat cracks while it is still curing. By 2007, the structure was rising a floor every 3 days. It topped out in 2009, in the middle of a financial crisis that stopped almost every other project in the Emirate, and it opened on 4 January 2010, 4 months after Dubai World asked its creditors for a standstill. The building went up on schedule, while the city that ordered it was renegotiating its debt. That timing matters, because the foundation of the Burj Khalifa was not built to last on its own. It was built to be defended, permanently. And defending something permanently is not an engineering problem. It is a bill that arrives every year for as long as the building exists, and it never gets smaller. It is worth being honest about what kind of decision that was. It was not reckless. The engineers on that job were among the best in the world, and they understood the chemistry precisely. What they could not do was make the choice on behalf of the people who will be paying for it in 2070. Somebody signed a permanent obligation for a city that did not exist yet, and then went to the ribbon cutting. This is what This channel exists to look at the part of a famous building that nobody photographs, and to follow the money that has to keep moving for the photograph to stay true. Subscribe now, because the next part is where the number stops being about concrete and starts being about the city sitting on top of it. Here is how this normally works. Anywhere on a salt coast, you protect steel inside concrete by making the concrete dense enough that chloride cannot travel through it quickly. The Portland Cement Association has published guidance on this for decades, and so has the American Concrete Institute. Cut the water in the mix. Add fly ash or silica fume so the pores between cement grains close up. Keep the reinforcement far enough back from the surface. Do those 3 things, and the steel stays passive for a long time. Engineers on the American Gulf Coast have been doing exactly this since the 1970s, and the bridge inspectors who follow them around know how well it holds. The team here did all 3, and pushed each one past normal practice. The raft was C50 self-consolidating concrete with 40% fly ash and a water-cement ratio of 0.34. The piles used a 60 megapascal triple blend with 25% fly ash and 7% silica fume at a water-cement ratio of 0.32. Those are not casual numbers. Lawrence C. Novak, one of the engineers involved in the structural design, later wrote the project up for the Portland Cement Association and described a mix program built specifically against the chemistry in that soil. The structural engineering itself was led by William F. Baker at Skidmore, Owings and Merrill. These were engineers with nothing left to prove and every reason to be careful, and the client paid for them to be careful. Then they did one more thing, and it is the thing this video is about. They installed a cathodic protection system underneath the raft. If you have not heard the term, you have almost certainly seen the principle. It is what the sacrificial anode does on a boat hull or inside your water heater. You wire the steel you want to save to a second piece of metal or to a power supply, and you push a small current through so that corrosion eats the sacrifice instead of the structure. It works. It has worked on ships and pipelines for over 100 years. But look at what it is. It is not a material, it is a machine. A machine has a service life, it needs somebody watching the readings, and somebody has to be paid to replace parts of it on a schedule that outlives the person who wrote the schedule. Engineers call the process that eventually ends reinforced concrete on a salt coast chloride-induced depassivation. Steel inside fresh concrete is protected by a thin oxide film that forms because the concrete around it is chemically alkaline. Chloride ions break that film down. Once it goes, the steel rusts. Rust occupies more volume than the steel it came from, and the concrete cracks outward from the inside. That is the mechanism, and it does not care how famous the building above it is. The second system is the one that surprises people. Dubai's groundwater is not sitting still. It is rising. In October 2025, Dubai Municipality Drainage Department announced a scheme called Resilient Future Flow, a 4-kilometer subsea outfall pipeline, 2 meters in diameter, able to discharge 9 cubic meters of water per second into the open sea. Fahd El-Awadi, the official who directs the drainage system at Dubai Municipality, gave the reason without decoration, and he did not soften it. Groundwater under parts of the emirate is rising by roughly 20 centimeters a year. That is about 8 inches. Every year. 8 inches sounds like nothing until you multiply it, or until you are the engineer who has to sign off on a basement built to a survey from 2005. Over 10 years, that is more than 6 feet of change in where the aggressive water sits against structures that were designed against a water table surveyed 20 years ago. Where is it coming from? Mostly from the city itself. Landscape irrigation in a place with almost no rain, leakage from pressurized networks run by Dubai Electricity and Water Authority, and treated effluent returned to the ground. Dubai has been pouring water into its own foundations for 30 years in order to keep the lawns green. Nobody decided to do that. It is the sum of a million small decisions that each looked harmless on the day somebody made them. The third force is money, and it arrives on a timetable. Dubai's answer to the water is a program called Tasrif, budgeted at 30 billion dirhams, roughly $8 billion, with a completion target of 2033. Officials have said it is meant to raise drainage capacity by 700% and move more than 20 million cubic meters of water a day. The first districts protected are Jebel Ali, Al Maktoum City, Expo City, and the Airport District. $8 billion is more than 5 times what the Burj Khalifa cost to build. The city is now spending several towers' worth of money on the water underneath the towers, and none of that spending will ever appear in a photograph. I want to put a person in this, because it is easy to talk about a building as though nobody works in it. Somewhere under the Burj Khalifa, there is a technician whose job includes reading the output of the cathodic protection system. It is not glamorous work. He checks reference cell potentials, writes them down, and compares this month against last month. If a number drifts, he files a report. Most months, nothing drifts. The report says so, and nobody reads it. That man is the reason the tallest building in the world will still be standing in any sense that matters in 100 years. Not the architect, not the developer who cut the ribbon in 2010. A maintenance technician reading a voltage on a Tuesday afternoon. Here is the part that should irritate you. When Dubai sells the Burj Khalifa, it sells the height. 2,717 feet, 163 floors. Tickets to the observation deck on level 148. Nobody has ever sold a ticket to the raft. The raft is the only part of the building that can end it, and it is the only part with no marketing budget at all. There is a second person worth putting in the frame, and she is the one who decides whether any of this continues. A facilities manager in that tower has a spreadsheet with a line on it for corrosion monitoring. Every year that line competes with lift refurbishment, with facade cleaning, with chiller replacement, with all the things residents actually complain about. Nobody has ever complained about a raft. That is exactly the problem. The item with the longest consequence has the quietest constituency in the building. And there is a third. Somebody bought an apartment on the 90th floor in 2013 and has paid service charges every year since. Some of that money goes to a system he has never seen, protecting a slab he will never stand on, against a chemical process nobody mentioned at the sales presentation. He is not being cheated. He is paying for something that was never described to him in the brochure, and if he sells the apartment tomorrow, the person who buys it inherits the same line without ever seeing it either. That is what makes this different from an ordinary maintenance cost. A lift gets replaced, and everybody notices. A facade gets cleaned, and everybody notices. The raft is the one asset in the building whose condition is invisible to every single person who has a financial stake in it. The only people who can see it are the technicians reading instruments, and they do not sit on the Owners Association board. So what do the engineers and the managers actually do? The first response is monitoring, and it is the one that works. The tower has been instrumented since construction. Settlement was tracked as it rose, and the published figures are reassuring rather than alarming. Maximum predicted long-term settlement was 80 millimeters, about 3.1 inches. The value measured when the structure reached level 135 was 30 millimeters, about 1.2 inches. That is comfortably inside prediction. Anybody telling you this building is sinking in a way that endangers it is not reading the numbers. The second response is the concrete chemistry itself. The fly ash and silica fume in those mixes are working right now, and unlike the cathodic protection system, they do not need electricity, a contract, or anybody's attention. They were the durable half of the strategy. Paying for them in 2004 looks better every year that passes. The third response is dewatering, and nobody enjoys it. Across Dubai, buildings with deep basements run pumps to hold the water table down. Pumps are equipment. Equipment fails, gets deferred, and gets cut when service charges come under pressure. A resident sees a line item on an invoice. A facilities manager sees a machine that has to keep running, or the basement changes chemistry within a season. The fourth response is the city-scale one, and that is tasrif. It is the admission, 30 billion dirhams in size, that this cannot be solved building by building. Notice which district sits at the top of the protected list. Jebel Ali, the industrial and port end of Dubai, where the emirate is also building its second Palm Island. The water problem and the expansion plan are pointed at the same stretch of coast, and only one of them gets a launch event. There is a fifth response that nobody talks about, and it is the one every old coastal city eventually reaches. You stop treating the structure as permanent and start treating it as something with a planned service life and a planned end. Bridges are managed this way. Ports are managed this way. Nobody has ever managed a national symbol that way, because the moment you publish a service life for a landmark, you have said out loud that it has an expiry date, and no government wants to be the one that said it first. Now hold those responses side by side, because the interesting thing is not any one of them. 3 of the 4 need somebody to keep paying and keep paying attention. Only one, the concrete chemistry, keeps working if everybody forgets. Dubai built a tower whose survival depends mostly on institutional continuity, in a city where the oldest modern institutions are younger than most of the people running them. Dubai Municipality, in its current form, is younger than the average American county road department. That is not a prediction of collapse. The honest version of this story is less exciting than the version that collects views. The Burj Khalifa is not falling down. The measurements say the opposite of that. What the building is doing is generating an obligation, quietly, every day, and that obligation was never really priced into anything. Think about what has to stay true for the next 100 years. A monitoring contract, has to keep being renewed by people who are not born yet. Anodes and rectifiers have to be replaced on schedule by somebody who understands why they matter. Groundwater has to be pushed back at 8 inches a year by a drainage program that will not be finished until 2033. And the emirate has to keep wanting to pay for all of it long after this stops being the tallest building on Earth, which it will, because Jeddah Tower has already passed 500 meters and started climbing again after a pause that lasted almost 10 years. The buyers who paid for those apartments bought a view. What they also bought, whether anybody explained it or not, is a share in a maintenance commitment with no end date written on it anywhere. So this is not an engineering failure. Nothing failed. The design is good, the mixes were excellent, the settlement numbers came in better than predicted, and the people who did the work knew exactly what they were dealing with. What expired is an assumption. The assumption was that the cost of a building is mostly the cost of putting it up. In ordinary ground, that is roughly true. In ground carrying 4.5% chloride, with a water table climbing 8 inches a year, it is not true at all. The construction invoice was the deposit. The real price is a subscription, and the renewal notices are already being paid by people who never watched the tower go up. Dubai did not get this wrong. Dubai got it early. Every coastal city with a deep basement is going to receive a version of the same bill, and most of them have not opened the envelope yet. Nothing in this video should be read as a claim that the Burj Khalifa is unsafe, and none of it is financial, investment, or policy advice. One question, and I would like a specific answer rather than a general one. If you have worked on cathodic protection anywhere, on a bridge, a pipeline, a jetty, a tank farm, how many years did the system actually run before somebody had to fight for the budget to service it? Put the number in the comments. That is the number this story really turns on, and I have never found anybody who publishes it.